Hey everybody, today is Wednesday, December the 2nd, and today we're going to be talking about patterns that we see in multiplication, and the two particular patterns we're going to look at for today are for 2 and 5 as factors. Now, we have learned so many different strategies so far about multiplication. We've learned repeated addition, we've learned arrays, we've learned grouping, we worked on the number line yesterday, and we're still going to be working on that number line throughout as well. So we're going to be doing these things all the way through multiplication, because what I'm trying to do is show you different strategies to use that you can find the one that makes sense to you, that you can use anytime that you're given a multiplication problem. So you've got to decide which one makes sense to you, which one works best for you. And I'm showing you these because you may be required to do them in an exam sometime in the future, but I also want you to be able to multiply numbers when you're giving those using strategies that we've been learning in class. So what we're going to do today is we're going to talk about patterns that we see for factors of 2 and 5. So our learning objective for today is I am learning to use patterns to multiply with 2 and 5 as factors. So again, we're going to focus on 2 and 5 today. The purpose for this is that we've already learned how to skip count by 2s and 5s. You learned how to do that in grades prior to 3rd grade. Today we're going to learn how to use that skip counting patterns to complete multiplication tables. Now, you have already been doing some of that prior to this lesson. We kind of talked about those things in previous lessons, and we're going to continue to follow through with that today, and we're going to specifically talk about 2s and 5s. So the next thing that we're going to look at is maybe some connections. What are some things in our real world that come in pairs or sets of 2? So think about something in your daily life that comes in sets of 2 that we call a pair. If you said any of the following, then you would be correct. But there's way more than that. So you may have come up with some things that I don't even have listed here. So we know shoes come in pairs. We have 2 pair in our shoes. We have 2 legs. We have 2 feet. We have 2 gloves. We have a pair of socks. So there's all kinds of things that come in pairs. So maybe you thought of these, and maybe you thought of some new ones that I don't have listed. So let's think about this particular problem. How can you find how many legs there are all together in a group of 9 chickens? After solving the problem, I want you to be able to explain the method that you use to solve it. So think about how you could determine the answer to this particular problem. I know there's some things that you've had to be thinking about here. We first have to know how many legs are on a chicken. So if we know that there are 2 legs on a chicken and we have a group of 9 chickens, what are some ways that you use to solve them? Now, since this is not a live lesson and I can't actually talk to you, I'm just going to come up with some ideas that maybe you came up with. You may have come up with different ways other than the ones I have listed, but here's just a few of those. You could have skip counted by 2s. And you would have skip counted you could have used your fingers, and you would have found out that if you were skip counting by 2s, that you would have said 2 9 times. You could have just simply multiplied 2 times 9. Some of you already know some of those basic multiplication facts. If you do, that's great as well. That's a strategy you can use. But if you don't know those basic facts, the other strategies that I'm teaching you will help you get the answer as well. Repeated addition, we could have just added 9 2 times. So we could have used repeated addition to help us there as well. And again, there's other ways that you could have solved that problem. You could have maybe drawn some groups and then put 2 in each one. So you could have drawn 9 groups to represent the 9 chickens and put 2 in each one of those to represent the legs. So there are all kinds of ways that you could have solved that particular problem. So let's think about how we can use small steps to help us. We can use skip counting patterns to find the 2's multiplication facts. So what I'm going to do is I'm going to show you on the next screen what the facts look like. And at the first row, the column is on the teaching tool. It's going to be what is 0 times 2. So we're going to start out and we're going to record those patterns for 0 times 2 and go forward. Now, we're also going to be thinking about that commutative property that we learned the other day. What does that tell us? What does that tell us about multiplication? I hope you're saying it's the order. Adeline, I believe it was, in our whole group the other day said, well, Miss Bays, that just flips the numbers around. Instead of 2 times 9, it just flipped it around to 9 times 2. The answer is going to be the same. So you can think of it as that flipping the numbers around. But the key word is order. We're switching the order of how we multiply those numbers. So on this next slide, you're going to see that if you switch the order, we have 0 times 2. We go all the way down, 1 times 2, 2 times 2, 3 times 2, 4 times 2. But when we come over to this side, we switched that order. We flipped them around, as some of you said. We flipped them around, and now we're doing 2's in the front and multiplying. So if we know what 0 times 2 is, then we know what 2 times 0 is. If we know what 6 times 2 is, then we know what 2 times 6 is. That pattern does not change. Now, we're going to look at the 5s because that's another one that we're getting ready to start talking about. And we're going to see that same pattern. That commutative property allows us to, if I already know that 3 times 5 equals 15, then all I've got to do is think about 5 times 3 and it's going to equal the exact same thing because my factors did not change, just the order in the way that I was multiplying them. So as you can see, we ended with 2 times 9 and 5 times 9. 2 times 9 equaled 18. 5 times 9 equals 45. That's going to be very important because in a few slides later, we're going to be extending those multiplication facts. But the first thing that we're going to do is we're going to talk about our academic vocabulary. We learned some academic vocabulary all throughout multiplication. We've learned about arrays. We learned about equal groups. We learned about repeated addition. We learned about what multiplying means. We learned what the answer to a multiplication problem is called, the product. We learned about the two numbers that we're multiplying. Those are called factors. Today we're going to be learning a vocabulary word called multiples. The answer or product that is received when multiplying two numbers. So if I were to say, is this a multiple of 2? If I can count by my 2's and say it, guess what? It's a multiple of 2. If I can count by my 9's and say it, then it's a multiple of 9. So multiples means that it's the answer or the product that we receive when we're multiplying. It's going to allow us to know that it's a multiple of the number that we're counting by. Okay, so multiples is your vocabulary word for today. Now, if you've got your journal at home that I had asked you to get for school, you can write these definitions in there so you can go back and refer to them just in case you need them to help you understand what they're actually asking in a problem. Now, I want you to think back to that table that we had. And suppose that for the table for the 2's facts, we continued on with 10 times 2, 11 times 2, and 12 times 2. How would you find the products for those numbers? Now think about what we ended on. We ended on 9 times 2. So if 9 times 2 is 18, how could we figure out what 10 times 2 is? How could we figure out what 2 times 11 is? Or 12 times 2? So again, think about those patterns and that skip counting that we used. Could you find 10 times 2, 10 times 11, or I'm sorry, 11 times 2, and 12 times 2? And I hope you said yes, because if we start at 2 times 9 equals 18, then I know if I count by my 2's 2 more, I'm going to get 10 times 2, which is 20. 11 times 2, 22. 12 times 2, 24. And then I can go down and do the same thing with 5 as the factor, as one of the factors. So if I'm doing, I know that 9 times 5 is 45, I'm going to add 5 to that, or skip count by 5. So 45, my next one, 10 times 5 is going to be 50. 11 times 5 is going to be 55. And 12 times 5 is going to equal 60. So again, you would skip count. You would skip count from 2's starting at 18 because that's where our table ended on 2 times 9. So, and then on the next one, you're going to start at 45 because that's where our table ended at 9 times 5. Here again is some of those notes that you might want to put in your journal or in your notebook that you're going to be using to help you with math class. Because when we're looking for patterns of two, and this is something that we need to keep in mind, we already know about even and odd numbers. Multiples of two are always, always, always going to be even numbers. So 2, 4, well, actually 0, 2, 4, 6, 8. Any number, and we kind of talked about this when we were in our classes at school that week. We talked about counting by our twos and what meant even and odd numbers, especially when we were doing our Friday game where you had to mark out any number that was even. We talked about even numbers always end in 0, 2, 4, 6, 8. So that's going to be important to you, that all numbers that are multiples of 2 are even, and that they all end in either 0, 2, 4, 6, or 8. Each multiple of 2 is 2 more than the one before. So just like we knew 9 times 2 is 18, we know that 2 more is going to be 20, 2 more is going to be 22, 2 more is going to be 24, and we could keep going with multiples of 2 by counting by our twos, or skip counting basically by our twos. So remember that multiples of 2 are always even, that they're always going to end in 0, 2, 4, 6, or 8, and that it's just 2 more than the one before when we're skip counting. Now, again, we're going to find those patterns for fives, and I love counting by my fives because I know that anytime that I'm counting by my fives, each multiple of 5 is either going to end in a 0 or a 5. So start counting, thinking about those. We have 5, 10, 10 ends in 0, 15, it ends in 5, 20, it ends in 0. So all multiples of 5 are either going to end in 0 or 5. So I can quickly look at a number and know, if I were to say the number 50, I know that's a multiple of 5 because it ends in 0. I know that 75 is a multiple of 5 because it ends in 5. So those things stick in my head. Those are those patterns that I need to kind of keep in my head so that I know when I see a number that it's a multiple of 5 because it ends in 0 or 5. And each multiple of 5 is 5 more than the one before, kind of like we talked about with twos. It's always going to be 5 more than the one that we said right before it. So those patterns are something I want you to keep in mind as you're working on your lessons. Now today for me, you're going to do the problem of the day, and then you're going to have 3 drag and drop slides that you're going to complete. They are going to involve um, commutative property. They're going to involve an array. So you're going to be using some strategies we've already learned and practice those just a little bit more on those 3 slides. Okay, so make sure that you get your work finished. And I want to tell you how excited I was to see some of your pictures where you played outside in the snow yesterday. So that made me happy to see those. If you played out in the snow, I would love to hear if you were able to build a snowman. I don't really know that there was enough snow to do that, but just tell me what you did outside yesterday. And if you didn't play outside and you've watched this video, just say, I didn't get to play outside, Miss Bay, so that I know that you have watched this video and are responding to what you did outside in the snow yesterday. You guys have a great day, and I'll see you later.